Welcome to our next highlight here on industry stage at Formnext 2024. Today we have the topic skills and talents for you. But before we start with our next session, I may have the one or the other hint or tip for you. In hall 12.0, in the booth number E22, you can find a free job application and photo shoot today until 4 o'clock. And if the one or the other is interested here in the hall or at home to hurriedly come to the exhibition, there is a direct exchange with potential new employers at the trade fair and a job wall to find vacancies and even a free career consultation today until 4 o'clock in the afternoon. So if it's interesting for you, make sure to step by in hall 12.0 booth E22. But now we want to start our session here, and it's time for lessons learned. Lessons learned is always good. You know, nobody loves to make the same mistake twice. And the lessons learned we will have today will be brought to you by Haden Quinlan. Haden Quinlan is the Senior Program Manager of the MIT Center for Additive and Advanced Production Technologies, APT. Since 2016, Haden has co-led MIT's industry-facing teaching efforts in additive manufacturing, and today he will present lessons learned from 10 years teaching additive at MIT. That's a lot of time, so the stage is yours. I hope you fill the gap, 10 years in your short presentation. The stage is yours.
Great, thank you so much, and thank you so much everyone for having me. Thank you for coming to this talk. Anyone who's heard an academic talk before knows that we tend to talk way too much, so I'm gonna do my best not to run over time, but please forgive me if I go a little long-winded. So as Sven said, my name is Haden Quinlan. A little bit about me. First and most importantly, I like to put embarrassing photos of myself on the slides. So here's one embarrassing photo of me wearing a bunch of PPE that we made during the pandemic. But simple overview, we spent 10 years teaching additive at MIT. We do that in a lot of different ways, online and in person, as I'll explain in a minute. And I do other things, lead MIT's industry engagements with the additive industry, as well as do some research projects, especially on process cost modeling and some particular applications focused in the infrastructure sector. Again, just a little bit about the program, just so you know what it is. I'm not here to market the program to you, but just to say that the center that I work for is really focused on translational research, on taking basic research, good ideas, and converting those into commercial practice, right? Trying to overcome what some folks call the valley of death, and we do that through advanced facilities, we do that through application-focused projects with industry members, and then most importantly, or maybe most pertinently to this talk, is we do that through workforce training programs. So what courses do we have? You're going to notice that I don't have a link to any course here. I'm not trying to market to you, just to tell you what they are. So we teach both online and in person. In person, we do that at the undergraduate and graduate level, teach MIT students. We also have training programs for industry, programs that you can sign up for and pay for with a credit card that we run on an annual basis. And then we'll do bespoke programs, one-to-one engagements with industry, something that we've started doing more and more recently. And I'm going to tell you why I think that's important in the direction that training needs to go later in this talk. Online, we have our flagship training program, Additive Manufacturing for Innovative Design and Production. You may notice we at MIT like very long names, but we just call this AMX to keep it short. And that's the course that, as when I say I've taught over 10,000 professionals in additive, like 9,000 of them or more come from the online training course. We also have another program called MIT Horizon, which isn't really a course per se, but more a resource that you can access. So what does our sort of journey look like? I mentioned there's 10 years here, and we can start in 2015 with our first training course for MIT students and go all the way to 2025, right? We haven't gotten there yet, but the future for us looks like focusing on industry particular training programs, application-specific training programs, and functional role-specific training programs. And I'm going to tell you why I think that's important and paint a picture for you of what I see as the future of workforce training and additive. But to do that, I want to make a few arguments based on where I came from. And so, title of this talk is Lessons Learned. I have 3 lessons for you. The first is that I think that additive training needs to progress from focusing strictly on design and beginning to focus on operations as well. And I'm saying it should include operations. Design is very important, but I think operations is also important and something that's very frequently overlooked in the training space. I'm going to try to make these arguments, right? This talk is called Lessons Learned. It's my perspective. So I'm going to try to make these arguments. I don't have like great data, but I want to sort of tell a story and use some visualizations to help do that. So when I say we should move from design to operations, I think we can start by looking at something simple like an organization chart. Obviously, this is not a full organization chart, but I think this is a good way for us to think about how does 3D printing training typically take place. And training typically tries to ask and answer 3 questions. For engineers, the question is, can I print this? Can the process form the material that I want it to? Can the process meet my functional requirements for my application? For decision makers, it's should I print it? And for a very long time, if you talk to folks in the education space, they would say that we need to move from can I print it to should I print it? I think we have that now. And then for the actual machine operators, right, how do I print it? And so this is what I would call traditional AM training, and that's offered by folks like ourselves at MIT, but also on the how do I do it side, often by the machine vendor themselves. You buy a machine, they come and they train you how to use it. Now, I don't think that's good enough, but I think it stems from where additive exists and where it has existed as an industry. So if we take a view of additive, where it fits across the product life cycle, right, traditionally additive has existed at the extremes of the product life cycle. The unit economics just make more sense. Additive per part costs are typically more expensive when we talk about very high production volumes, but early on in the product life cycle for prototyping or for spare parts, those unit economics make more sense. And so for a very long time, the industry said, how do we get to production additive? And the way that we do that is we do that through design excellence, by designing parts and products that only can be made by additive and are so good that they justify an increased cost when I choose printing versus a conventional forming process. But when we actually say now that we're actually in a time of production, right? Not for every process, not for every industry, but certainly there are many, many more production use cases of additive. We need to now ask the question of, okay, we're starting to produce parts at scale. What does that imply for training and workforce development? And the argument that I would make is if we go back to our org chart, right, this is not enough. We now need to think about all the other roles within an organization that need to be trained in additive. And the fact is, you might think like HR, accounting, so on, this is not so important. Additive is fundamentally technology. But I would argue, no, there are many more questions and many important questions when you start to broaden your perspective, right? If we look at the supply chain, we might say, how do I think about a make versus buy decision in additive? If I want to buy printed parts, how do I qualify my supplier? How do I manage risk? And to my knowledge, I could be wrong. I don't know every training course in the world. I don't think there's any one additive training course that focuses on supply chain professionals. We can say the same things about even the topic of this talk, skills and talent. What kind of competencies do folks in additive need? How do I deliver those competencies? What kind of curriculum should I develop? So on and so forth. And when we have that broad organization-wide view, and we think about additive as a real mature production technology, which you can debate me if that's the case or not, but certainly we need to broaden our horizon in how we teach. So that's the first lesson. The second lesson that I'd say is, again, about getting more specific, starting to think about what production additive means, and I would argue that general training is not particularly useful. And you might point at me, if you're familiar with our courses, and say, Haden, MIT's courses are general. And I'll say, yeah, I know, for now. And the thing is that I feel like the training needs to move towards application and industry-specific focus areas. And again, I want to make that argument from a general perspective, right? So imagine for a moment you're new to the technology, and you know your parts, your products very well. You think additive could be a great fit for us. Maybe we're like a low volume, high mix manufacturer, and we make metal parts. Okay, so imagine that's the company that you are, and you come to a trade show like Formnext, and you say, okay, I'm gonna 3D print in metal. What process am I going to choose? Well, you have a lot of options. And this is really confusing. And so if you have general training that tries to boil the ocean and tries to teach all of this stuff to everyone, right, the fact is it's become very, very hard to make an impact. People get confused, they get lost, they start chasing particular technologies, and they don't know what's real. So I don't think that teaching at this broad view makes a ton of sense. I think we need to get more focused. We need to meet the customer, the manufacturer where they are, understand what they're trying to make, how they can make it, and the role of the educator is to help navigate them through this massive wheel of process technologies, not to just hand them the wheel and say, you figure it out yourself. And you could make the same argument. Again, these are generic graphics. I just took them, first one from Ampower, this from a research paper, right? But let's say you figured out, okay, I can do powder bed fusion, I can do binder jetting for my parts. How do I down select? How do I identify the right process, the right machine? There might be multiple steps. Those steps involve cost calculation. Those steps involved design engineering work, design for additive manufacturing, right? There's time, there's resources, there's dollars spent, or euros spent in sort of figuring this problem out. And on the left-hand side of this graphic, I added some things because there are many commercial tools available, consultants, commercial resources, software packages, et cetera, that can help you. But each one of those comes with a cost, and it comes with another learning curve associated with it. And sometimes the costs can be very, very high. If you want very, very sophisticated, high-fidelity software, like on the cost modeling side, right, the licenses can be really, really pretty extreme. And so, again, if I'm an educator, and I think of my job as helping you, whoever you are, right, go from where you're starting in additive to where you want to go, helping you engineer an application and actually make parts. If I want to be able to do that, I need to be able to get specific. And so that's the second lesson, is we need to start focusing on those particular applications, particular industries, meeting companies where they are, rather than providing this very generic training, which may or may not be particularly useful. I'm sorry, I spoke really fast because I thought I'd run out of time. I'm not gonna, so I'll slow down just a little bit. And then the third lesson, this one is a little bit looser because this one is just straight up my experience, but the third one is sort of a cry for help for decision makers, and to say, please consider, if you're thinking about sending your employees through additive training, please consider the format of that training as the most important thing to the impact that you expect to receive. Because some folks take a training and they take it from us, and they say, MIT is really good. MIT, best university in the world, at least for engineering. Surely it's going to be good training. And then they send folks to MIT for like 4 hours, and they don't learn very much, and they come back and they say, what the heck? We didn't get much out of this. And in reality, right, again, I don't have great graphics here, but I just want to sort of present what we call like the time paradox, is that in our online course, in our public-facing programs, the online course is 12 weeks long. That's 3 months. That's a lot of time. So about half the folks that take that course, based on our exit survey data, say that's too much material. The paradox is that more than half say, yeah, but I want more. They want more in specific focus areas. They want more in cost accounting for additive. They want more in particular process technologies. And so I think there's some nuance there, and I'll explain how I think we can try to kind of solve this paradox by giving more content, but doing it in a way which is more focused and allowing folks to have, let's say, a shorter and more impactful training experience. In our private programs, again, this is where the call for help comes from, is that it's very, very hard for me to convince a decision maker that they should send 20 of their employees to MIT for more than a week. And even a week is very difficult. Most folks say, 2-3 days, that's the most that we can give up. Now, realistically, how much can you learn in 3 days at MIT? And the answer is honestly not that much, right? If we want to get into application engineering type topics, and ideally we do, we want to work with a customer, we want to look at their parts, print those parts, iterate, define a post-processing strategy, and so on, right? 3 days, we may not even get to a single print, because the first day we'll spend looking at the file, distilling that part down into its fundamental requirements. In almost all cases, the first part we'll look at is something designed for casting or machining, not designed for additive, so we'll want to make a design modification. We'll also then need to evaluate what process can we use to print it, and we might need to make further design modifications based on that manufacturing process, as well as the post-processing strategy, especially if we want to machine a metal part after we 3D print it. And then on the third day, we might get to build preparation. So if I spend 3 days at MIT, I might print a part at the last day. If I spend a week at MIT, I might print I might get 2 part cycles. If the part is a short runtime, I can print it overnight on the 3rd day, pick it up on the 4th, and run another job on the 4th day. So for the folks, the industry users, the folks who have engaged with additive, who are operators of the technology, right? If I told you you had 5 days only to go from a part that was designed for casting to a part that was designed and is possible to 3D print at scale, right? Would you tell me that's a reasonable time frame? I think most of you would say I'm crazy. And yet often it's the case that when we talk to decision makers, they say, I only want short training, I can't free up resources. Well, I promise anyone in the audience, anyone watching, I think it's like only my fiance, hello, but if anyone else is watching, then let me just say, you're not gonna get much out of that, and you'll probably spend more money in failed prints and wasted material over the long run than you would if you had sent folks to a training course for 2 weeks or 3 weeks, rather than just saying, a week or 3 days is the most that I can do. So, what principles can we derive from these 3 lessons? How should we design training programs in the future? And I didn't do this on purpose, but I have 3 M words for you. The 4th is MIT. But I think there's sort of 3 principles that we can look to in the future. So the first is that I think courses ought to be modular. And by modular, I mean highly focused content, which is technically rich, but is focused on particular subject areas like cost accounting for laser powder bed fusion, right? Or processing TIE 6.4 with XYZ technology. This is the way that we can sort of solve this time paradox where folks can say, yeah, I want more content, I can get more in the specific area of interest, but I don't have to spend as much time globally because I'm not going through materials that aren't that relevant to me. I also think that content should be matrixed, and by matrixed I mean we need to map modules not just to the actual subject area, but we need to map those to industries, and in particular map those to functional roles within an organization. And then last, I think multimodality is very important, right? Most of our students are online students. And online is great in a sense. Online is very scalable. It's very low cost. It's easy to teach certain things online, right? Additive is very digital technology, so generative design or build preparation are things that I can sort of teach in an online environment. But again, anyone who has run a 3D printer for a significant amount of time realizes that the best learning in additive often comes from the pain of figuring out the process and making mistakes. And if you don't get hands-on training, you never have the opportunity to experience that pain, to make those mistakes and realize how to do things better in the future. And so I think that as we start to map competencies, think about how additive needs to be translated to skills across the organization, right? We want to think not about who can take online training and be successful with that, but also make sure that we have opportunities for folks that need to go further with the technology to go further with the technology. And last but not least, I'll say that I think there needs to be greater connectivity, at least in the US, between training providers. And here, I'll give a shout out to Europe. I think Europe's much further along than we are in the United States on this front. But we need some standards. We need to come together and define what does an additive manufacturing LPBF process engineer need to know. And align on that so that it's not as confusing for the end customer, for the person being trained, so that they can make better decisions about what training program makes sense. I think it's also important for the workforce to be able to empower folks with professional certifications that are nationally or internationally recognized. And at the moment in the US, we don't quite have that. So the way folks look at training is they just say, which name is better and which syllabus looks better based on what I want. And I think we can make more of an impact there. Now, let me give you an example of how we could implement these types of principles in practice. This is just an exemplary program structure. It is not the real one for our future coursework, but hopefully it gives a sense of what I mean by modular and matrixed, right? Is that we have many different focus areas. Those focus areas are more tight, are more compact. These might be 1-week modules, 2-week modules, no longer. But then we can map those modules to different job functions within the organization, and we can start to build customized programs very, very easily by taking these modules and stacking them up like Lego bricks until we have a finished program at the very end. Now, that's more or less all I have to say about training, but I want to end with kind of something I think is insightful when we think about the journey of additive, where it is today and where it goes in the future. And I want to draw a parallel between 3D printing and CNC machining. And so if we look at the CNC machine, right? The CNC machine was invented more or less in the 1950s. About 1953, this is when this photo is from, there's one CNC mill in the entire world. It was actually NC mill at that time. One NC mill in the entire world. And CNC back in the day is a lot like additive in that you needed very customized skill sets and very customized machinery to make it work, right? Originally, only like 3M, the 3M Corporation could make the tapes that gave the machine instructions, and only GE could punch those tapes out and encode them with a toolpath. So back in the day in 1953, there was one NC mill. It was really, really hard to operate. And if we fast forward 45 years in the future to 1999, there was only 20 to 40% adoption within manufacturing of CAD, computer-aided engineering, and CNC. So it took a very, very long time for CNC to penetrate, and the argument that this paper makes in sort of the middle, the middle image that you see, is that it was the diffusion of CAM, computer-aided machining, and CAE, computer-aided engineering, such that when, actually CAD as well, that when there was enough digital infrastructure to make CNC easier to use, then folks started to use CNC machines much more often. And now if we look at today, right, this says 2023, but you know, it's 2024. There's more than 600,000 CNC machines in the world. We have many companies at the show like Meltio, DMG Mori, and others who have very advanced and sophisticated equipment, combining additive and subtractive manufacturing processes, but it took a really, really long time to get there. And so I think the job of educators is to try to play the role that CAD CAE did for CNC machining, and play that role in trying to make things easy and facilitate the conversion to additive or the adoption of additive for certain parts at production scale. So with that, that's all I have to say. If you want to send me an email, you want to talk about anything, please feel free to do so. If you are interested in the course, I'm legally obligated by my marketing department to put the link up there, but for sure we can chat about it if you're interested. Thank you so much for your attention. Appreciate y'all being here.
A round of applause for Haden. So Haden, thank you very much. Very, very fast forward your presentation, but full packed with infos. Great. I just checked the live stream, LinkedIn live stream. There were no comments or questions. If you allow me, we have some seconds left here on stage together. Sure. If you allow me one question, we have today's a day skills and talents, and in Hall 12 there are some activities for young students, for people who want to start into the business. What would your advice be when these young people are looking for a company? Which are the questions they should ask, or the aspects they should focus on when looking at the right company to choose?
That's an interesting one. I think ultimately it depends on what you want to do, how you envision the way I always look at this is like, what career do you want to have shouldn't be what job title or what company do you want to work for. It's what do you want to do on a day-to-day basis. And I was having a really interesting chat with an engineer yesterday, like the head of design engineering, who said he loved additive. He got involved in additive because it involved a little bit of everything. It wasn't just component design, it wasn't just quality or material science, but it involved all of those pieces, and for him that was very exciting. So my suggestion is, don't focus so much on the company or on the title, but focus on what daily work looks like. And if that sounds something that's exciting to you, you'll probably have a good time.
Maybe the products can help. When you look at the products the company is producing, that could be a part of the equation. Or could it be helpful to look at the industry sector? Is it differently to work or to start work in a company who is producing parts for automotive compared to another in medicine? I think it's so.
Well, there should be different amounts of stress involved for sure. I mean, like high volume production with tight margins and so on, you can expect to get yelled at once or twice. But I think that's important. It's like if you find work meaningful, particularly meaningful, you feel like you're making an impact in the world, for sure that can help. But ultimately, I still just think it's about figuring out, is my day job going to really, there's an expression, right? If you love what you do, you never actually work a day in your life. And I think that obviously we all hope that to be the case. We're not always so lucky. Maybe you are, but I think that's where everyone should aspire to be.
Maybe that is a very good advice for all of us. Thank you very much, Haden, for being with us, for sharing your insight. And if you want to have contact to Haden, he's still a bit around. Where can I find you at the exhibition?
I'll hang out here because I'm on a panel in a little bit. So, you can come and
okay,
stop
so
by.
make sure to make contact with him or use our LinkedIn live stream, and then you can ask your question, and you will check if there are certain questions for you.
Sounds good. Thank you so much.
Thank you very much, Hayden. And a round of applause for Hayden. Yeah, I'm looking at the next part. We have a next highlight block, and we will see you again in some minutes.